All right, so we're going to first start out by finding the component form of a vector. So to find the component form of a vector, you have to start with the terminal side and subtract the initial from it. So our terminal point is 2, 8, and our initial is 6, -3. So we're going to start with our horizontal components, so 6 minus 2. And then our vertical components, so -3 minus 8. And then we get our vector, which is 4, -11. Notice when I'm writing my vector, I do not use parentheses. That is the difference between a vector and a coordinate. Parentheses is a coordinate. These half triangles, the greater than, less than signs, are how we represent a vector. So that is our vector in component form. Now to find the magnitude, that's just finding the hypotenuse, or the length of the vector. So I take the square root of my horizontal component squared plus my vertical component squared. So I get the square root of 16 plus 121, which is the square root of 137. If the radical simplifies, you should simplify the radical. We're going to call this vector v, and then this is the magnitude of vector v. So that is how you represent a vector in component form, and that is how you find the magnitude, or the length, of a vector. So now let's do some operations with vectors. So if we're given vector u, which is 2, -1, and vector v, which is -4, -3, and I want to find the result of doing 2 times u plus v, there's two ways to do it. One way is graphically, and the other way is algebraically. So I'm going to first start off by showing you how to do this graphically. So if we have vector u, graphically, if you're not given an initial and terminal points, by default, your initial is your origin. So we're going to start at 0, 0, and then go right to down 1, because it has a horizontal component of +2 and a vertical component of -1. So that is vector u. So I'm going to multiply vector u by 2, meaning the length, the magnitude of that vector has doubled. So my horizontal component of 2 now becomes a horizontal component of 4. And my vertical component of -1 now becomes a vertical component of -2. So my vector 2u looks like that. Now I'm taking vector 2u and I'm adding v to it. So now from the terminal point of the vector 2u, I will now draw in the vector v. So from the terminal point of 2u, I'm going to go, left 4, 1, 2, 3, 4, and down 1, 2, 3, to the point 0, -5. So that was vector v. So that means my vector 2u plus v is this vector right here. Has an initial side of 0, 0 and a terminal side of 0, -5. So that's graphically how you can add, multiply, subtract vectors. Algebraically, it works just like normal coordinates. Add your x's with your x's, your y's with your y's. So if I have 2 times u plus v, I'm going to follow my order of operations, do 2 times u first, which gives me 4, -2. And now I'm going to add that to vector v. So I end up getting the vector 0, -5, which, if we take a look, is that vector there. So how we find the vector graphically, how we find the vector algebraically. Find the resulting vector of v minus u. So we're going to first start, I'm going to erase this work here. So let's first start with vector v, which is -4, -3. So I'm going to go left 4, down 3, from the origin. So there's my vector v. And then minus u. So if I did plus u, from my terminal side, I would go right 2, down 1. But since I'm doing the opposite of u, I'm going to go left 2 and up 1. So that's the opposite of u. So my result, when I add v and the opposite of u together, is that vector there. So graphically, I got my vector. Algebraically, I'm going to take vector v, which is -4, -3, and subtract vector u from it, which is 2, -1. So that's the same thing as doing vector v plus the opposite of vector u, or -6, -2. And if we verify, that is in fact that vector. Horizontal component of -6 and a vertical component of -2. I have zero preference whether you do these algebraically or do them graphically, but it is important that you understand how to do it both ways. All right, example 4. Find a unit vector in the direction of v and verify that it has a magnitude of 1. So a unit vector is a vector that has the same exact direction, but it has a magnitude of 1. So if you take a vector, any vector, and divide it by its magnitude, it's going to end up having a magnitude of 1. So the first thing I need to do is find the magnitude of vector v. So to find the magnitude of vector v, we take the square root of the horizontal component squared plus the vertical component squared, which ends up giving us the square root of 4 plus 9, which is the square root of 13. So my unit vector that's in the direction of vector v, we'll call that vector u, will be vector v divided by its magnitude. So that ends up giving us -2 square root 13 over 13 for our horizontal component, and 3 square root 13 over 13 for our vertical component. So that is my unit vector that is in the same direction as v, but only has a magnitude, meaning length, of 1. Now, how can I verify that? Well, let's just find the magnitude of that unit vector. So to find the magnitude of my unit vector, I take my horizontal component, -2 square root 13 over 13, and I square it, and then add it to my vertical component, 3 square root of 13 over 13, and square that, and take the square root of that. So that gives me the square root of, let's see, that is 2 times 13, which is 26, over 169, plus 3 times, oh no, not, whoops, I did that wrong. Reverse, reverse, erase, erase. All right, I'm going to do that step by step. So that will be 4 times 13 all over 13 squared, which is 169, plus that'll be 9 times 13 over 169. So I multiply and add, and that gives me the square root of 169 over 169, which is the square root of 1, which is in fact 1. So that's just verifying that that unit vector definitely has a magnitude of 1. But that makes sense. If you take a vector and you divide it by its length, it's going to end up having a length of 1. So 5. Let v be the vector with initial point 2, -5, and terminal point, let me move that. Oops. Okay, undo, 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 undo. All right, let me, there we go, move it. All right. Initial point 2, -5, and terminal point -1, 3, right? V is a linear combination of the standard unit vectors I and j. So first things first, let's find the component form of this vector v. So my terminal side is -1, 3. My initial point is 2, -5. So I'm going to have -1 minus 2 and 3 plus 5. So vector v has a horizontal component of -3 and a vertical component of 8. So that's the component form of vector v. So this linear combination of our standard unit vectors means I'm going to take -3, multiply it by I, and 8, multiply it by j. So all we're literally doing is saying that this is -3 times I plus 8 times j, which is -3, 0, plus 0, 8, which is -3, 8. So all we're doing is we're taking the component form and rewriting it in terms of I and j because it'll end up being a lot easier looking at it like a linear equation, a linear combination later when we do harder stuff with vectors than it will be in component form. But the two forms are equivalent to each other. So whether you do component form or linear combination using of our standard unit vectors, it's all the same mathematically. Alright, so hopefully this video helped you out if you were having a hard time understanding the notes. Homework tonight is in your book, so with your remaining time, please pull up the online book if you don't have your hard copy and get working on your homework. I'll see you all tomorrow.